In this lesson on percent error, we are going to learn just a little bit what it means to compare an estimate to an actual amount and portray that amount as a percentage. Being able to estimate values accurately and appropriately will be an extremely valuable thing to have in your arsenal in your adult life. What do we estimate? Well, businesses can estimate sales that they will make of a particular item. We can estimate the bills that we have to pay. We can estimate time, so how much time it's going to take us to get from point A to point B, or how much time it's going to take for a task to be completed. We can estimate performance, anything that can be measured numerically, like performance in a sporting event. So we can estimate how many points someone will score. We can estimate how long it will take for someone to complete a race, so that's performance. We can also estimate how students will score on assessments or how humans will score on any kind of assessment. We can also estimate averages. Frequently, estimates are close to actual amounts, but are rarely exact. The amount in which estimates are off from the actual amount in comparison with the actual amount is called percent error. So if, for example, I think 6 out of 30 students will earn an A on the percents test, I brought something with me, I'll find it. After grading, I see that 9 students earned an A. What was my percent of error? Well, I am going to compare how much I was off. I was off by 3 because I thought 6 would earn an A, and it turns out that 9 did. So I was off by 3. And if I compare that numerically and in a ratio format to the number of students who actually got an A, I will see that I was off by 33 1/3%, because 3 out of 9, 3 divided by 9 is 0.3 repeating. 0.3 repeating converts to the percentage 33 1/3%. Here are a couple more examples of percent error. Before the season began, I thought the Lions would win at least 10 games, right? They actually won 7. What was my percent of error? So, how much was I off by? I was off by 3 games, and then they actually won 7. So 3 divided by 7 is going to be the math that I will do here, and it turns out to be 0.42857, etc. So we can use this here. If I said round to the nearest 10th percent, I said it was 0.4285. So this decimal as a percentage is 42.85%. So we'll say that it's 42.9% error. Okay. Every weekend I take a trip to the grocery store. Last week I thought I would spend about $60. However, I ended up spending $115. So what was my percent of error? Well, I thought that I would spend 60. Clearly, I was wrong. So what is the difference between what I spent and what I thought I would spend? Well, that's 115 minus 60, which turns out to be 55. I'm going to take that amount and divide it by the actual amount I spent. 55 divided by 115 is 0.4782. So 4,782 10,000ths. If I take this and convert it to a percent by multiplying by 100, I will see that I have a percent error of 47.8%. So what this means is that I was off by almost 50%. If I had doubled what I thought I was going to pay, that $60 I assumed is half of what actually happened, being that it would be half of would be 50% of. And then lastly, we've got 4 students who estimated how they performed on a quiz. So we are going to find the percent of error for each student. Student A thought that they would earn a 95 on the quiz and actually earned a 90. Well, they were off by 5 and they actually earned a 90. So we would set this up, 5 out of 90, and do the division. And we would get 0.05 repeating. So this 0.05 repeating, multiply our decimal value by 100, and we get 5.5% error. So they were off by about 5.5%. Okay? Here, the student estimated that they would get a 100, and they actually got a 100. So they were not off by anything. They were actually exactly right. And we divide that by 100, and that's 0%. So there is no error at all. Makes sense, right? Then we have a student who estimated that they got a 60, and they actually earned an 80. Not bad. Well, they were off by 20%, or 20 in their estimate, not 20%, 20 points, excuse me. And they actually earned an 80. So if I divide 20 by 80, well, you can already tell that that's going to simplify to 1/4. So that's a 25% error. And then lastly, I have a student who assumed they would get an 80 on the quiz and earned a 96. So that's a difference of 16 out of the original, which is 96. Looks like this. And that turns out to be 0.16 repeating. So that's about 17% error. Okay? So the closer your estimate is to the actual, the smaller your percent error. The further away you are from your actual value, the larger your percent error.